Hi guys, so today we are going to be looking at the moles and the molar mass. I am using the book Chemistry and another book, the name of the book is Atoms, and this is an OpenStax book which is the initiative of the Rice University. Okay, so when we talk about the moles, before that let's try to understand that what is moles and where does it come from. Moles is a unit that is used to determine the weight of the particles and the number of particles. Okay, so just like you have a unit, for example, if there is a unit of 12, like 12 of something, that is equal to 1 dozen of that thing, right? For example, you have 12 pens, or you have 12 phones, or you have 12 books. They're all going to be 1 dozen. 12 shoes, 12 chairs, 12 candies, all of them 1 dozen. Okay, so same is the case. Every particle will, that is 1 dozen will have a different weight depending upon what we are looking at. The pens, the candies, the shoes, the books, the cars, the tables, chairs, the bottles, and you name it, the weights is going to differ, right? So the same thing with the moles also. Moles, we equate 1 mole of anything that is equal to the Avogadro's number. And the Avogadro's number is 6.022 into 10 to the power 23 particles of that something. And what is the weight? The weight of those particles, whatever the weight comes out to be in grams. Now, here's the thing. 1 mole, let us say, for example, 1 mole of 1 mole of pens. And how many pens these are? 6.022 into 10 to the power 23 pens. Okay, and what is the weight of those pens? You put that many pens, whatever their weight comes out to be in grams. So that is the weight of that 1 mole of those pens. Okay, then 1 mole of, let's say, candies. So how many candies are we looking at? We are looking at the Avogadro's number of candies. And what is the weight of those candies? You put the candies on the machine and you weigh them, and whatever the weight comes out in grams, that is going to be the weight of those candies. That's 6.022 10 to the power 23 candies. Okay, so similarly, you take 1 mole of let's say cars. Now that's a huge 1 mole of cards. How many cards are we looking at? We are looking at 6.022 into 10 to the power 23 cars. And what is the weight of the cars? If you somehow get the weight of those cars in, that's going to be the weight in grams. Okay, similarly, let's just look one more example. 1 mole of books. How many books are we looking at? We are looking the Avogadro's number of books, which is 6.022 into 10 to the power 23 books. And if you put those books on a weighing machine, whatever the weight comes out to be, that is the weight of those books in that one mole of those books. Okay, so you see the weight varying. The weight varies from the entity that we have in question. So if we have pens, obviously the weight is different. We have candies, the weight is going to differ. We have cars, the weight is definitely going to be very, very different. And if we have the books, and depending how many books, or depending what kind of books, like small size book, large size books, so those things depends. Again, the weight is going to vary. Same thing, if you're going to apply the same concept to, let us say now, one mole of atoms is equal to 6.022 into 10 to the power 23 atoms. And what is the weight? That is the mass number, and that is the mass number in grams. So mass number of that atom. Okay, and that is that mass number of the atom in grams. And whatever that atom is. Okay, so we're going to look at this in a minute, more details. 1 mole of molecules are going to be here, depending what molecule is. Okay, whether it's a covalent compound or it's an ionic compound, still the weight is still going to, it will have a common, now we are not using the formula mass or the molecular mass, but 1 mole of the molecule is the Avogadro's number of the molecule, and this is going to be equal to the weight of that molecule, or the mass of the molecule you can just write down here, the molecular mass or the formula mass, depending upon what we are using. If it's an ionic compound, formula mass, molecular compound, molecular mass, and regardless, whatever the weight is in grams. Okay, so now let's look at an example of one mole example is example, and here we have this example of 1 mole of, let us say, 1 mole of fluorine, F is fluorine. Remember, example, F stands for fluorine, Fluorine. Okay. Okay, so here 1 mole of fluorine, how many particles, how many atoms of fluorine are there? 6.022 into 10 to the power 23 atoms of fluorine. Okay, and what is the weight of that? The weight is the mass number. So look in the periodic table, look at fluorine, you see the mass number is the number 19, the heavier one. So that is 19.00 grams. And with that said, that is why this is also called the molar mass of fluorine. That is molar mass of fluorine. And what is that? This is 19.00 grams per mole. And this means 19 grams of fluorine are present in 1 mole. In 1 mole. So this is the way we can understand the unit also. Okay, so and in this 19 grams of fluorine, in other words, contain 19 grams of fluorine contains 6.022 into 10 to the power 23 atoms. Okay, now, so this molar mass has all this information into it. That's what it it means. So generally the molar mass, the unit is grams per mole, and then we can expand on it further. Now let us look at from this the different types of conversion factors here. So different conversion factors, conversion factors. Okay, now what are those conversion factors? Now we are going to look at the conversion factors. Let's say, for example, let's look at aluminum. Okay, aluminum, for example, aluminum is 13 is the atomic number, and 26.98 is the mass number. So this is the atomic number, and you're not going to use this one, but you're going to use this one, which is the mass number. And this mass number is the actual weight of this atom. So let's look at the conversion factors here. So we will see that 1 mole of aluminum, first let's write this down. 1 mole of aluminum contains 6.022 into 10 to the power 23 atoms of aluminum. And what is the weight of those? The weight, let us just round this up for now, that is 27 grams of aluminum. Okay, so that's the equality. Now the conversion factors are 1 mole of aluminum contains 6.022 into 10 to the power 23 atoms of aluminum. The other conversion factor is 6.022 into 10 to the power 23 atoms of aluminum are present in 1 mole of aluminum. Okay, next is, we can also look at it, 1 mole of aluminum contains 27 grams of aluminum, or 27 grams of aluminum is present in 1 mole of aluminum. Okay, the next is, we can also look at it, the relationship between the Avogadro's number that is 23, 6.022 10 to the power 23 atoms of aluminum are present in 27 grams of aluminum, or 27 grams of aluminum contains 6.022 into 10 to the power 23 atoms of aluminum. Okay, so these are the different conversion factors. Now, as we had learned it in the dimensional analysis, and I'm just going to do a little review here, that the entity, so you are going to have something that is given to you in the question. So given units, okay, given units times. Now here is going to be the unit that you want. The units that are wanted are going to be on the top. The units that you want to remove are going to be at the bottom. Okay, so on the top is the numerator. This is the unit that you desire. And this is the same unit as this unit. So remove this unit. Okay, so this unit, so we see that these units cancel out, and we are only left with the unit that we want. Okay, so this is the eventually, so this basically used, that's why these are conversion factors, because these are used to convert. Okay, so now we are going to look at the terms. This was a situation with the example with fluorine. This is the atoms, where we looked at the atoms. Now let's look at the molecules. So in the molecules, how do the moles come out to be? So molecules are made up of two or more atoms that are chemically combined. So two or more atoms, when they are combined, chemically combined in a definite ratio. Okay, chemically combined in a very definite ratio. Okay, so then these are molecules, make the molecules, and molecules are entirely new species. Okay, now, so let us look at a molecule of like H2O. Okay, H2O, simple one. So H2O is made up of two atoms of hydrogen and one atom of oxygen. Okay, so that's the combination is 2:1 of hydrogen to oxygen. So that's one thing, and we are going to be looking at in our next chapter, or in the next unit, sorry, how to calculate the empirical and the molecular formulas. So it's very important you understand the moles in this case. Okay, so here we have the two atoms of hydrogen, one atom of oxygen. Okay, so this two atoms of hydrogen and one atom of oxygen, let's calculate the formula mass, or sorry, the molecular weight, or the molecular mass. Molecular mass. So two atoms of hydrogen, 1 gram each, one atom of oxygen, 16 grams each. The weight is equal to 2 plus 16 comes out to be, so when you add these, comes out to be 18 grams per mole. Okay, so that is the molar mass. We just now calculated yes, this is the molecular mass, but this is also called the molar mass. That's the more commonly used term now, is the molar mass, because it really helps us see how many atoms are we dealing with, or how many molecules are we dealing with. So this is the molar mass. Okay, so molar mass of hydrogen and oxygen combined together making water. So how do we write this? So this means 1 mole of water is 18 grams of water, and this contains 6.022 into 10 to the power 23 molecules of water. That is the difference. Molecules of H2O. Okay, so that's one thing. Now the next thing is that same conversion factors. And I just want to write this, so you know it's kind of a review also for you guys. So conversion factors. Now what are these conversion factors? Conversion factors here are going to be 1 mole of water over, okay, 18 grams of water. That's the weight. Or 18 grams of water over 1 mole of water. Okay, so this is one conversion factor. Another conversion factor is 18 grams of water contains 6.022 into 10 to the power 23 molecules of water. Molecules of water. And here 6.022 into 10 to the power 23 molecules of water are present in 18 grams of water. So this makes more sense to us that when we are taking these weights, we should know how many molecules or how many atoms or how many particles are we dealing with. Okay, next we are going to look at the 18, how much was that? Yeah, 1 mole, which is the other one? Grams and molecules, moles and grams, and then, yeah, so 1 mole of water contains 6.022 into 10 to the power 23 molecules. Okay, molecules of water. Okay, 1 molecule, 6.022. So here is 6.022 into 10 to the power 23 molecules of water are present in 1 mole of water. Okay, so these are the conversion factors. Now, there's something very interesting. In the periodic table, okay, in the periodic table, you are given this information that you see here. These are 1 mole. 1 mole of every substance. 1 mole of hydrogen, 1 mole of nitrogen, 1 mole of iron, 1 mole of chlorine, bromine, iodine, aluminum, silicon, phosphorus, nitrogen, oxygen, ruthenium, polonium, you name it, whatever. So these are 1 mole. Each one of these elements that you see in the periodic table is 1 mole. That's the information about 1 mole. Okay, so we looked at the information regarding the fluorine atoms, we looked at the information regarding the molecules, and now let us look at this one example. And this is an example from a learning check problem, and that is that, let's write this down. This is the learning check. Okay, so in a learning check problem, we see that beryllium is a light metal. It is used to fabricate transparent X-ray windows for the medical imaging instruments. How many moles of beryllium? The question is asking how many moles of beryllium are in a thin foil, or in a thin foil window weighing, or a thin foil weighing 3.24 grams. Okay, so there are a few things here. You are given 3.24 grams. You need to find how many moles, the number of moles, and what particle are we dealing with? We are dealing with beryllium. Okay, how many moles of beryllium are present in? So given is given 3.24 grams of beryllium. Find, the question is asking you to find the moles of beryllium. Okay, so here we are going to have some information already known to us. We know that, and that information is coming from the periodic table. So from the periodic table, we know that beryllium, Be, beryllium stands for, like 4 is the atomic number and 9.012, and it's safe to use 9, just 9, it's fine. Okay, so 9 is the mass number, okay, for our calculations. So beryllium, so we are going to, this is like we talked about, this is the atomic number, and this one is the mass number. So when you look at the mass number, right, that's the weight. So that's the one we are going to use. So 1 mole of beryllium. So this is the information we know that from the periodic table, that 1 mole of beryllium is equal to 9 grams. Okay, so in other words, 9 is the molar, 9 grams per mole. This information, this is the information you get from the periodic table. All right, so let's make this a nicer arrow. Here is the nicer arrow. Okay, 9 grams. Now, the question is, you are given 3.24 grams of beryllium. So write down 3.24 grams beryllium, multiply by, and here you are going to find out the unit that you want. You want how many moles? So moles go on the top and the grams going to be at the bottom. And you're going to use this information that you obtain from the periodic table as your conversion factor. Okay, so that conversion factor is that we see that grams, 9 grams, 1 mole. Okay, so this beryllium, so this mass number, basically, I'm going to just put it right here. So 9, the mass number of 9, mass number in beryllium is 9. And the molar mass of beryllium from the periodic table is 9 grams per mole. And this thing gets translated as 9 grams over 1 mole of beryllium. This is beryllium and this is beryllium, or 1 mole of beryllium over 9 grams of beryllium. So these are the two conversion factors, and the one that we are going to use is, we are going to use this one, 1 mole of beryllium. So this is the one that we put here. Okay, we put this here because we want to find the moles. So that is why the unit, the thing that you want to find, is the one that is going to be in the numerator. Numerator is the one that is on the top. Denominator is the one that is going to be in the bottom. So the fact of these fractions, denominator. Okay, so denominator is the one that gets cancelled out. This one gets cancelled out when you do this, and this is the one that remains. This is the one that you eventually, the question, the one that's asking you to find. Okay, so as you can see, the grams of beryllium, and here you have the 9 grams of beryllium, 1 mole of beryllium. So here you are seeing that the 9 grams, so the grams of beryllium and the grams of beryllium cancel out. Okay, so all you are left now is 3.24 times 1 divided by 9. Okay, so Let's do the math now. Okay, so when we did the math, we looked at that 3.24. So here is versus 3.24, and we took that 3.24 times 1 divided by 9, and we get 0.36 moles of beryllium. Okay, so that is going to be your answer. Now we are going to just, I want to just keep this on one side so it doesn't mess up. Okay, now we are going to look at another example in which we are going to be mass of so this particular conversion was the conversion of grams to moles. Okay, converting the grams to moles using the you know the an atom, an element. Next, we are going to do another example, and that is going to be converting the moles of a substance to grams of that substance. Okay, so this one was the grams to moles. Let me write this down properly. Grams to moles. So that's the one example. This is A. And next we are looking at the learning check and learning check problem, and that is in which we are doing the conversion given moles to grams. Okay, so here we are given gold. We're going to look at gold. AU stands for gold. And what do we know, first of all, from the periodic table, even before we start looking at other things? So gold, AU, is 79 and 197. Okay, so again, this is the atomic number, and this is the mass number. Okay, so same thing, 197, what does it mean? It means that 197 grams of gold is present in 1 mole of gold. Okay, and this also means 1 mole of gold contains 197 grams of gold. Okay, so this is basically the mass number, or the molar mass of gold, as it's commonly said, is the 197 grams per mole. Okay, so that got into, those were the conversion factors. Okay, so now very clearly we see that the question here is asking you, you are given 2.56 moles of gold. Okay, you are given 2.56, given 2.561 moles of gold. What is the mass? Find the mass, and that mass is in grams. Find the mass in grams. How much is that? So we are going to write down what is given to us, which is 2.561 moles. Multiply by, now we are going to cancel out the moles. So that we don't want. The question is clearly asking us for grams. So you write down the grams on the top and the moles at the bottom. Grams of gold, moles of gold. Okay, so what do we know? 1 mole of gold contains 197 grams. Okay, so with that, we are going to cancel out the, this is going to be gold. So we are going to cancel out the moles of gold, and we are only left with the grams of gold. So when you do the math, which is 2.561 times 197 divided by 1. Okay, and that should give you 504.4 grams, okay, of gold. So this is the basic grams to mole conversion, moles to grams conversions, okay. So that was like one piece. Next, we can also look at the deriving the grams of moles from a compound, and deriving the we're going to look at deriving the moles from the grams of a compound. Okay, let's look at this. Another set is the deriving the, but like in other words, a compound. When we talk about a compound means that now we are looking at the molecule. Remember that every element, when we talk about element, we talk about the smallest unit of the element is the atom. But when we talk about compound, we talk about the molecule. Okay, so now we are looking at the how many moles of sucrose. So here's a question: how many moles of sucrose? Now this is an organic compound, and its formula is C12H22O11. Okay, are given in are how many moles are present in 25 grams sample of sucrose. Okay, how many moles of sucrose C12H22O11 are in 25 grams of that sample? So how are you going to do this? You are going to take, you are given the formula of sucrose, you're given the grams, and this is the steps. So you are given the grams, and you need to find the moles. And the way to do that is you go through the molar mass. Very important. Molar mass for grams to moles conversion. Okay, so first thing first, we are going to look at the molar mass of sucrose. C12H22O11. This means that there are 12 carbons. Each carbon is 12 grams, but there are 22 hydrogens. Each hydrogen is 1 gram. There are 11 oxygens, and each is 16 grams. Okay, so let's take the weight of this first. Okay, so now we calculated the molar mass of sucrose. So 12 grams of carbon, each weighing 12, 144 grams, 22 grams, 22 hydrogens, each weighing 1, 22 grams, 11 atoms of oxygen, each weighing 16, 176 grams. Added together, all of this, when you add together, you get 342 grams per mole. Remember, this was in the previous, in the earlier phase of this chapter, this was the molecular mass. And this molecular mass in the olden days was also called a molecular weight. And this now we commonly used is molar mass, which is more exact because it gives us a sense of how many particles or how many molecules of sucrose are we dealing with. And that is, that is contained in 342 grams. So in other words, 342 grams is present in, is the weight of 1 mole of the sucrose. Okay, so now we are just going to follow this particular roadmap, which is converting grams to moles using the molar mass. So we are given 25 gram sample of sucrose, 25, so write down 25 grams of C12H22O11. 12H22O11 times, we need to get rid of the grams. So write down the grams of C12H22O11. Okay, and that is 342 grams, and that is present in 1 mole of C12H22O11. And now we will see that the grams of sucrose and the grams of sucrose cancel out. Okay, and we are only left with the moles. So now you are going to write down the answer, the computation: 25 times 1 divided by 342, and that should give you 0.073 moles of C12H22O11. Okay, so this is the grams to mole conversion. Next is, sorry, this was the grams. This was the grams to mole conversions. We are going to look at next example, which is of the moles to grams, number of atoms. Yeah, moles to grams conversion. So let us just do this one example. If you are given, let's say, the moles of, you are given, this is one example. Let me just write this on. How many, this is the moles to grams conversion example. Okay, so moles to grams here, how many grams are present in 2.5 moles of Al2SO4 whole thrice. Okay, how many grams are present in 25 moles of aluminum sulfate? That's an example. Okay, so here you are going to, first thing in this case also is that we follow this roadmap. You are given 2.5 moles. The entity that is in question is aluminum sulfate. How many grams? This is what we are trying to find. How many grams, right? So write down what is given to you. You are given the moles, 2.5 moles of Al2SO4 whole thrice. And you need to find out how many grams of aluminum sulfate. That is Al2SO4 whole thrice. Okay, and you are going through the conversion involves using the molar mass of aluminum sulfate. All right, so there's no direct conversion. You have to get the molar mass and then you convert it. So let's do that first. Let's calculate the molar mass of Al2SO4 whole thrice. So first thing first, keep this in mind that this 2 applies to aluminum, this 3 applies to sulfur, this 3 applies to oxygen. So that means that there are 2 aluminums, there are 3 sulfurs, and there are 3 times 4, that's 12 oxygens. Okay, so here we have 2 aluminums, each weighing 27 grams, 3 sulfurs, each weighing 32 grams, 12 oxygens, each weighing 16 grams. So we get the weight of this in a minute. Okay, so now what we see here is that when we calculate the molar mass of aluminum sulfate, we get 2 aluminums, each weighing 27 grams equals 54, 3 sulfurs, each weighing 32 grams equals 96, and 12 of oxygens, each weighing 16 grams, and that equals 192. When you add this whole thing up, it comes out to be 342 grams per mole. Now just don't forget that 342 grams of Al2SO4 whole thrice means that this is equal to 1 mole of this Al2SO4 whole thrice. So this also means that 34 grams is present in 1 mole. Sorry, it's not 34, it's 342. My mistake here, I'm sorry. This is 342 grams, okay? So we have here 342 grams of aluminum sulfate is present in 1 mole, or 1 mole of aluminum sulfate contains 342 grams, okay? 342 grams of that material. So if you weigh 344 grams on a weighing machine of aluminum sulfate, you are technically weighing 1 mole of that, and you're technically weighing 6.022 into 10 to the power 23 molecules of Al2SO4 whole thrice. Okay, so that's the interesting part. But anyways, let's do this now. So we are given 2.5 moles and we need to convert it into the grams, right? So we are given 2.5 moles, convert to gram using the molar mass. So just write down this again. 2.5 grams of Al2SO4 whole thrice, multiply by 1, we need to convert it into moles, right? I forgot. No, grams, sorry. That is the grams. Sorry, this is the moles is given. These are the 2.5 moles of aluminum sulfate, and we are converted into the grams. So out of these, since the gram is on the top, we are going to be using this conversion factor, okay? Because we need to find the grams. So that's the unit we want. So 342 grams of Al2SO4 whole thrice. And that gives you 1 mole of Al2SO4 whole thrice. Okay, so now we are going to moles of aluminum sulfate cancel out, and only the grams is left. So next thing you're going to do is that 2.5 moles, 2.5 times 342 divided by 1. And you are going to get the answer 342 times 2.5, and that is 855. 855 grams of Al2SO4 whole thrice. Okay, so this is the moles to grams conversion, grams to moles conversion. Then we looked at the concept of moles. We looked at the concept regarding the molecules and the atoms. And yeah, so this is like the basic stuff. And there is another piece that let's just cover that one also, which is we are given the number of atoms, and that we can find the number of moles, or we can find the number of one second, here, deriving the number of atoms from the mass of an element. Okay, so here you are given the one example, and that is again a learning check problem, and it's a learning check problem. Okay, and in that learning check, we are going to see that we are given the number of atoms, and you can convert it to the grams, or if you're given the grams, you can calculate how many atoms are there as far as the elements are concerned. And the same thing, you can find the molecules if you are given the grams. And if you're given the grams for the compounds, you can find how many molecules there are. Okay, so the mass of the copper, for example, the mass of the copper atom is given to you. No, sorry, this is the gold here. So you are given, in the learning check problem, you are given 15 grams of gold. Okay, 15 grams of gold is given to you. How many gold atoms are in this quantity of gold? How many atoms of gold are there in 15 grams of gold? Okay, so this is given. And here you need to find this. So this is how you set up your problems. And since this is gold, so that's why it's atoms. So now what do we know? We know there are certain things we know which is not going to be given to you. So you should just know this. What do you know? We know that 1 mole of something, let's say 1 mole of gold, in this case, is going to contain 6.022 into 10 to the power 23 atoms of gold. Okay, and that, what is the weight of that? The weight you're going to get from the periodic table. And in that periodic table, you see that the gold is 197 grams of gold. Okay, so now we have 1 mole of gold. So we are looking at, basically out of these three, we are looking at a relationship of the grams, and we are looking at the number of atoms. So we are going to be focusing now on this thing, these two equalities. So what does this mean? This means that 6.022 into 10 to the power 23 atoms of gold are present in 197 grams of gold, or 197 grams of gold contains 6.022 into 10 to the power 23 atoms of gold. Okay. 2. So which one are we going to use? We need to find the number of atoms, find the atoms in gold. So find the atoms in gold. Atoms in gold is on the top. Okay, we are given the grams, we want to get rid of the grams only then. So this is what you need to, this is the one that allows you to find. So you are going to be using this conversion factor. Okay, so next thing what we are putting here is that 15 grams of gold, 15 grams of gold times 197 grams of gold. Get rid of that one. This is what we need to find, the atoms of gold. Okay, atoms of gold. And what do we see here? That the gold, grams and grams of gold cancel out. These two units cancel out. And you are left with 15 times 6.022 into 10 to the power 23. Divided by 197. 197. Okay, so this whole thing is going to give you 4.586 into 10 to the power 22 atoms of gold. Atoms of gold. Okay, so we're going to stop here, and we are going to look at further, conversions and finding the empirical and the molecular formulas from there. Okay, so thank you for watching and appreciate your time. Take care.